Okay, next one is 2x squared plus 5x minus 12 equals 0. So we're going to go ahead and start with factoring. So when you're factoring, you want the equation to equal 0, which it does. And then we ask ourselves is there a GCF? So something that goes into 2, 5, and 12. So all three of these terms. And for this one, no, there is not. So then we ask ourselves how many terms? There's 1, 2, 3. When there's 3 terms, we're going to take A and C and multiply them together. So that would be 2 times negative 12, and that's negative 24. So we have to find out what multiplies to negative 24, and it has to add to 5. So that's what we're looking for. Okay, so since it has to add to a positive, I know the bigger number is positive, and the other number, the smaller number, is negative, because a negative and a positive make a negative, but it has to add to a positive. So that's how I know the smaller one's the negative. And then I would see that negative 3 and 8 would add to 5, and they multiply to negative 24. Now, if we remember back to when we first learned factoring, I did show you how to factor this problem keeping it as 3 terms and how to factor it by grouping. So I will, in this video, show both ways to review that. So if you want to keep it with 3 terms, you're going to put your 2 parentheses here. And then you're going to take this 2 and this x right here, and you're going to put a 2x here and a 2x here. Now again, keep in mind, 2x times 2x is 4x squared. So we're going to have to take something out here in a second. Then we're going to put our negative 3 that we found here and our 8. It doesn't matter as long as the 8's the positive one. And then again, this does not FOIL, does not multiply to this original problem. So what we have to do is ask ourselves, does anything divide into 2 and 3? No, other than 1. No. And then does anything go into 2 and 8? 2 does. So I'm going to do, in my head, 2 divided by 2 is 1x, and 2 divided by 8 is 4. Now, that extra 2 was removed out of this group here. So now we could see that this would FOIL. If I do 2x times x, that's 2x squared, and then negative 3 times positive 4 is negative 12. Now I'm going to get the 5 because this would be 8x, and then this would be negative 3x, and 8x and 3x, negative 3x, would make the 5x. So it does FOIL if you multiply it out to the original, so we checked it. Okay, so then once it's in factored form, we're going to set each of these equal to 0. So we'd have 2x minus 3 equals 0, and then x plus 4 equals 0. And we would get x equals 3/2 as one solution. And then our other solution is x equals negative 4. Okay, so now I'm going to take it, I'm going to go ahead and factor it again. So instead, the other way to do it, which a lot of other instructors do it this way, so I like you to be familiar with this method as well, even if you find this way easier, is you're going to take out this term right here, get rid of it, and rewrite the problem as it is, except for when you get to this, you're going to plug in, and it doesn't matter which one goes first. So I'm going to have the negative 3x, and I have to put the x there, and then I have to put the x there. So I'm taking these two numbers because negative 3x plus 8x is the same thing as 5x. So I'm taking this term out and replacing it with 2 terms that combine to make it. So I'm making this problem into 4 terms. Okay, so this is the alternative, is change the 3 terms into 4, and then you solve by grouping. So you're going to group 2 of them together, and then you're going to do the GCF of the group here. So what do these both have in common is just an x. So then x times 2x is 2x squared, and x times negative 3 is negative 3x. Then we go over here. What goes into 8 and 12 is 4. So 4 times 2x is 8x, and 4 times negative 3 is negative 12. Now, if we did this correct, these two should match. So they both have 2x minus 3 in common. So I'm essentially taking the GCF out of this and this, which is 2x minus 3. So that's why I bring down the 2x minus 3. And then I'm going to put the x and the 4 together, because when I put them together in a parenthesis like this, it's saying take the x and distribute it to both of these and take the 4. That's exactly what this whole thing says. That's why you just put these two together and bring down just one of them. The reason why you're not bringing down 2x minus 3s, just to review that again, is because the x and the 4 are both being multiplied by just a 2x minus 3. There's not two of them. Okay, and then you will see that you will get the same thing we got here. And then you would set each of these equal to 0, and that's how you get your 3/2 and your negative 4. All right, so let's go ahead and repeat this with completing the square. Okay, with completing the square, we want the constant over here. And we also want this to be a 1. So it doesn't matter which one goes first, whether you put the constant over or whether you make the front number a 1. So if I want this to be a 1, I need to divide by 2, because 2 divided by 2 would be 1. So whatever I do to one side, I have to do to the other side. So we're going to divide everything by 2 to make this a 1. Now, personally, when I am trying to decide what method to use, when I have a fraction right here, I personally like to avoid problems that have fractions, because you make more mistakes that way. So that's why I wouldn't use completing the square for this one if I had the choice, but we're going to continue to show how it would work. So again, completing the square, we need to put a number here that will make this factorable. But keep in mind, it already was. So that's why, again, I wouldn't choose this method. But it still works, because we're trying to make it factorable as a perfect square. So I'm going to take this 5/2, and I'm going to divide it by 2. So 5/2 divided by 2. And then I'm going to ask the calculator to make it an improper fraction. So that's 5/4. So again, to review what the calculator is doing, it's doing 5/2, and then you know your rule when you divide is to flip it. So it's flipping it. So this is why the calculator got 5 times 1 is 5 and 2 times 2 is 4. Okay, so then after we divide by 2, then we take this 5/4 and we square it. So 5 squared is 25, 4 squared is 16. So on my calculator, I could just click the square button and then ask it to change it to an improper. And then there's that 25/16. So we're going to have to add 25/16 to both sides. And again, this is why I personally wouldn't choose this method if I had the choice, because I always like to choose the method if I didn't have a calculator, what would be easier. This isn't too bad because, again, we have a calculator, so then we don't have to find a common denominator. The calculator will do that. So I could do 6 plus 25/16. Then we're going to change it to an improper fraction, and we get 121/16. And then here, we're trying to factor this as a perfect square. So we're trying to figure out what multiplies to 25/16, and it has to add to 5/2. Now that sounds really confusing, but if you showed your work here, the answer to that question is always what you get before you square. So this number right here that you're squaring. So 5/4 times 5/4 is 20. 5 times 5 is 25. 4 times 4 is 16. And then when you add them, 5 plus 5 is 10, and you keep the denominator the same when you're adding. And then if you simplify that, you get 5/2. So it does work. So in factored form, this is x plus 5/4 times x plus 5/4. But the point is we want to write it as a square. So that's x plus 5/4 squared. So now we can square root both sides. And since this index is a 2, 2 divides 2 and once, so this will go away. And whatever we do to this side, we have to do over here. So we need that plus or minus. So we have x plus 5/4. And then the square root of 121 is 11. And then the square root of 16 is 4. Now to get rid of this 5/4, we're going to go ahead and subtract 5/4 on both sides. And then we get x equals, so we're going to have 11 minus 5, which is 6/4. And then 2 goes into both of these. So we would get 3/2. So that's one answer. And then we would get negative 11 minus 5. That's negative 16/4, which negative 16 divided by 4 is negative 4. Okay, so that was without a calculator. We want to use a calculator just to show how it works. If I do 11/4 minus 5/4, we get 1.5, so then we change it to an improper. So there's the 3/2, and then we would have negative 11/4 minus 5/4, negative 4. Okay, so let's go ahead and try it one last way. Let's go ahead and use the quadratic formula. So when using the quadratic formula, a is the number in front of the x squared, b is the number in front of the x, and c is the constant. So we're going to go ahead and plug that into our quadratic formula. So we would have negative b plus or minus b squared minus 4ac all over 2a. So we have 5 squared is 25, and then here we're entering that in as negative 4 times 2 times negative 12, and that is a positive 96. 2 times 2 is 4. So then we have 25 plus 96, which is 121. Okay. And next thing we do when we get it into this situation here is we always tackle the radical first. So the square root of 121, what times itself is 121? That is 11. So we would have negative 5 plus 11. So negative 5 plus 11, that would be 6 divided by 4, and then 2 goes into both of these. So we'd get 3/2. And then we would do negative 5 minus 11, that's negative 16/4, which is negative 4. So again, we get those same two answers using the quadratic formula. So I think if I was to do this problem, I either would have used factoring or quadratic formula. I probably would have gone with quadratic formula if I had the option.